Hey guys, in this video I'm going to be going over exception handling in Java. Exception handling is just another term for error handling. So when you run your program and the user types in an integer and you were expecting a string, or vice versa, or maybe you have a division by zero. Maybe if you try to open a file that doesn't exist, all these things can generate errors that will crash your program. So today we're going to look at ways of handling those errors or exceptions in a more graceful way. A lot of this should look familiar to you. If you've seen it in C++, we use the try-catch blocks the same as C++ does. However, in Java, the exceptions that are generated are all objects, just like everything else in Java. Every exception has its own class, and they are all derived from a class called throwable, and I'll show you that in the Java documentation here. If we go over to the Java API and look under the throwable class, you have errors and you have exceptions. So if I click on exceptions here, there are several subclasses that handle all different types of exceptions that can be generated. Most common are going to be runtime exceptions. So I'm going to click on that link right there, and then from runtime exceptions we also have several other subclasses. One that you might see is arithmetic exception. So if you try to divide by 0 or take the square root of a negative number, you may end up with some arithmetic exception. Whenever your program executes that line that causes that error, Java creates an object from this class, and the result of that object is what you will see in the output. So it crashes your program, but it also creates an object from one of these classes. Another real common one is index out of bounds. If you have an array that goes out of bounds, you try to access an element that does not exist. Let's click on that. You'll have an array index out of bounds exception thrown. And I will give you an example of that here in just a minute. These are probably some of the most common because index out of bounds exceptions are never caught by the IDE. You only find them at runtime. So let's look at that. I'm going to create an array of integers. So let's say I've got an array of 10 integers here, and I just want to initialize all of these guys to some value. So I'm going to do that with a for loop. I'll say I less than 10, I plus plus, and then a sub I equals I. We'll just set it equal to I. If I run this guy, that works just fine because I'm accessing elements 0 through 9. 10 is never accessed, so that's no problem. However, if I put an equal sign there, then the for loop is going to execute one more time, and it's going to try to access element A10, which we know does not exist. So let's run it, and I get exception in thread main. So this red down here is part of the exception that was generated by that array index out of bound class, and we get this error right here, just like I showed you over in the Java docs. So to prevent that sort of thing from happening, what we can do is wrap our for loop in a try-catch block. So I can say try, open braces, close braces, and then catch. And catch is like a function, so it gets parentheses and then braces. And inside the catch parentheses, we give the name of the error that we're hoping to catch. So I know I'm working with an array. It's possible to get this index out of bounds here. So I say array index out of bounds, and then I give it a name. We'll just call it X. Not really important what you call it right there. Within the braces of the catch block, I can do something like print out an error message. So just say index out of bounds, and that just gives the user some idea of what happened. The beauty of doing it this way instead of just letting it crash and burn with that error message is the program will keep running with the catch block. So let me try to format this. There we go. And I run the program again. Notice there's no red. The program does not crash. I do get the index out of bounds, so the error was generated and the catch block caught it and it handled it with whatever code I want to write in that catch block. Okay, so the important thing to know is that the catch block never runs if the error is never generated. So let's fix my for loop up here. I'm going to stay within the bounds of the array. I run the program and I get no output because if there is no error, the catch block never runs. Another important thing to note is that this catch block will only catch an error that matches the description in the parentheses. So if I had an arithmetic error up here, let's say if I was dividing by, just say I was setting these values equal to 5 divided by I, well, I is going to start at 0, so that should generate an error. But it won't be an index out of range error, it'll be an arithmetic error. So let's run the program, and notice the catch block did not catch that one. I would need a different catch block for this arithmetic exception. So I'll copy that guy here, and I can put as many catch blocks as I want, kind of like else if statements. And I will just say catch, paste that guy in there, and handle it with the same type of message. Division by 0 in this case. So now we run the program again. I get my division by 0 error. If I go out of bounds here, run the program, I still get my division by 0 because I'm still dividing by 0. And that's the first one that hit. There we go. Index out of bounds. So the catch block will catch whatever error is generated. Now, if we keep in mind that all of these errors are objects, and due to inheritance they are all exceptions, I may be able to catch both of them if I just declare this catch block as an exception. Instead of specifying a particular error, which you may want to do in some cases, but in other cases it may be easier just to say exception, which encompasses everything, every exception that is derived from the exception class. Or I could do runtime exception and catch all the runtime exceptions. But if I do that and I run the program, notice I still get my index out of bounds. If I fix that problem and go back to division by 0 here, it still catches the error. It says index out of bounds because that's my message, but you see it caught the error. It will catch any error that's generated as long as it's derived from the exception class. So that's a little bit more general way of handling it, but at the same time you don't really know what the exception was or what happened, or less details but easier to program. So there's a try-catch block. Let's look at another example. Let's say we're doing something with user input. So we'll say print enter a number, and then we'll write a scanner, and we say, well, we need someplace to store our input, so I'll say int num, and then s dot next int. I'm looking for an integer, so I use next int. And then I'll try to print out that integer just to make sure it works. The number was no. What's it mad about? It says num might not have been initialized. There we go, num equals 0. Now it's initialized. We get input from the user. We set that equal to num, and then we print it out. Let's see what happens. Enter a number. I type in 5. It works just fine. I run it again. I type in something that's not a number. Oh, crash and burn. So input mismatch exception, another exception here. So I'm going to copy that guy, and then I'm going to wrap my input statement in a try-catch block. So I'll say try to get the next int, and then catch I didn't copy the whole thing. Catch input mismatch exception. Call it X. Put some code in here. And in this code, I'm going to say you must enter a number. Remember that these are classes, so I need to fix my imports. And now it recognizes that. And let's run the program again. Enter a number. I enter a number. The number was 5. It works just fine. Enter a number. I enter garbage. It says you must enter a number. So my program doesn't crash. My catch block caught it. It handled it. And then it says my number was 0 because that's what I initialized it to. But we could make this a little more robust. We could put this in a loop, right? So I will just say do and then while num does not equal 0, or while num equals 0. We'll loop that right there. And this is going to cause a little problem, but I'll show you how to handle it. If we do it now and we type in garbage, the loop is working, but the scanner is stuck. So one way of handling that is to reset the scanner in the catch block. I'll go ahead and kill my program here and just say s equals new scanner. That's one of the easiest ways to handle it. Maybe not the most proper way of handling it, but either way, it works. So now let's try it again. Enter a number. I put in garbage. You must enter a number. I put in garbage again. Doesn't work. Now let's actually put in a number, and the program runs just fine. So there's a great way to validate your input. Even if they type in something they shouldn't, you can handle it with a try-catch block and prevent your program from crashing. So in a way, that's pretty cool. One thing to note when you're using a try-catch block, anything you initialize or anything you create, say like I create int j here, inside the try-catch block, the scope of this variable is limited to the try block. It's just like if statements or for loops or functions or anything else that gets wrapped in braces. It has a limited scope. So oftentimes you will be required to declare your variables outside of the try-catch block and then just set them, like I've done here with num, inside the try-catch block. So try-catch blocks do limit the scope of your variables. That's one of the most annoying things about working with them. But they also offer us a great way of handling errors and keeping our programs robust. Alright. Give me just a second here. That's pretty much it for try-catch blocks. That gives you enough to do the lab that I'm going to have you do. There's also a way to throw errors, and we'll look at that when we go over file input and output. You can avoid, see, Java will make you use try-catch blocks when you try to do certain things, and when you try to open a file, read a file, write to a file, anything like that, Java enforces try-catch blocks. The program will not even run if you don't wrap your code in a try-catch block, because it's afraid you'll try to open a file that does not exist. But you can throw that exception and avoid having to do this. Not always the best approach, but it can be done, so I'm going to show it to you in the next video.